You're welcome to this other wonderful lesson where we are going to cover a lot of stuff and actually it is integration. I don't know why my heart is too much taken to differentiation. We're looking at integration of inverse trigonometric functions. It has some aspect of differentiation. I think that's why my heart was too deep into differentiation. So under this, we are going to cover the sine substitution and the tan substitution. Look, it is known that when you take the derivative, I'm going to begin with the derivative of the sine inverse of x. Okay, this one is equals to 1 over root 1 minus x squared. One may ask themselves how. So let me set you a reminder from differentiation. The reminder is that when you're differentiating the sine inverse of x, I want to show you how we get this, how we get 1 over this. So in other words, if you let y to be equal to that sine inverse of x, it means that sine y is equals to x. So if sine y is equals to x, I took sine either sides. So this side you get sine y and this side you get x. In that, when you want y still, you will get it sine inverse of x. So now you differentiate both sides with respect to x. So if you differentiate with respect to x, when you differentiate the sine, you get cos. So it is going to be cos y dy dx is equals to, when you differentiate x, you get 1. But from cos squared y plus sine squared y is equals to 1, okay, we can really see that cos squared y is equals to 1 minus sine squared y, meaning that if we need cos y alone, it is the square root of 1 minus sine squared y. That is after taking the square root both sides, implying that here I would substitute for cos y as this. Okay, but remember, I can continue and say that cos y will be equaling to the root of 1 minus sine y was equal to x, meaning sine squared y is x squared. So that one means that if I substitute cos y as this, we shall have from here, we shall have that the root of 1 minus x squared dy dx is equals to 1, implying that dy dx, which is our derivative, dy dx is equals to 1 over the square root of 1 minus x squared. This is quite interesting. Now, having this known, now we have confirmed that the derivative of sine inverse of x is equals to 1 over the root of 1 minus x squared, implying that when you apply an integral both sides, okay, when you integrate this, when you apply an integral both sides, it means that the integral of 1 over root 1 minus x squared dx now is the sine inverse of x plus a constant of integration. So we are going to look at how this one comes about, and at the same time, we are going to look at the integrals that apply sine rule. The integral that applies, we apply sine substitution. So now, we're going to look at this concept, all this result will be enable us to integrate all functions of the form okay, all functions of the form integral of 1 over the square root of a squared minus b squared x squared. So remember, our integral brought 1 over 1 minus x squared under root. So we are going to look at integrals of this format or of that nature, or integrals whose result is as the same as what we looked at previously. So we are going to entirely look at how we apply, all right, how we apply the integral, okay, how we apply the integral, and we use the sign substitution to bring out the concept that we are really interested in. So I'm going to begin with a concept that may be integrate. This is like an introduction still. We want to see how we can integrate the function of this form. So integrate the integral, or find, let me say it like this. Let me say find one over square root of a squared minus b squared x squared dx. Because we said that the result of sign substitution is applied to the integrals of this form. Now, see, we are going to say, as a solution, we are going to say that the integral of 1 over square root of a squared minus b squared x squared dx is the same as the integral of 1 over, now here, we can substitute a squared out, or rather we can factorize out a squared. So if you factorize out a squared, it's going to be a squared. Remember, we want it in the form 1 minus x squared under root 1 over. We want it in this form. So you have to ensure that you create a 1. So that's why I've factorized out a squared so that it becomes 1 minus b squared x squared over a squared. Because when you multiply it inside, when you multiply this a squared, it goes back to this. Because when you multiply it here, it will cancel and it keeps b squared x squared, which is this. So this is the same as the integral 1 over this square root affects even a squared. So the square root of a squared is a. So now that one you can move it out. Then this one is not having a direct square root. So it will keep 1 over, rather 1 minus b squared x squared over a squared. You can have it like that. But for this case here, you can really, all of them, since they are all squared, you can work on it and you reduce it to 1 over a, okay, square root of 1 minus bx out of a squared then dx. Then we shall let this result of the square to be maybe sine theta. So we shall say let bx out of a be equal to sine theta. It implies that when you differentiate both sides, all right, anyway, here you can even get what theta is equal to. So theta is the sine inverse of bx out of a, all right? So if theta is equal to sine inverse bx over a, still now you can differentiate both sides. When you differentiate both sides, here is a constant of x. So when you differentiate bx over a, you remain with b over a dx. is equals to, when you differentiate sine, you get cos. So it will be cos theta d theta. All right, cos theta d theta. It implies that when you make dx the subject, our dx is going to be equal to, of course, you're going to cross multiply. So it is going to be a over b cos theta d theta. So after making dx the subject, then it means that the integral now becomes integral of 1 over a root of 1 minus bx over a was sine theta. So meaning when it is squared, it becomes sine theta, sine squared theta. And this result dx, now our dx is a over b cos theta d theta. A will cancel with the a, and we can bring 1 over b outside. So it is going to be 1 over b integral of 1 over 1 minus sine squared theta is the same as cos squared theta. Cos squared theta, that is from cos squared theta plus sine squared theta is equals to 1. So it means that sine squared, cos squared theta is 1 minus sine squared theta. So that's why I'm bringing it here. Then times cos theta d theta. So this is the same as 1 over b integral 1 over square root of cos squared theta is cos theta times cos theta, all right, d theta. Cos theta and cos theta will cancel, shall remain with 1 over b integral of d theta. And when you differentiate, when you integrate d theta, you'll get theta. So theta plus c. But theta is sine inverse of bx over a. So the whole result will become 1 over b sine inverse of theta, which is bx over a plus a constant of integration. So that is what we are having when we differentiate, rather when we integrate such a question. So we are going to look at examples that involve integration and application of sign substitution. So let's see examples. One, find all right, so if you're looking for this, if you're finding this integral, you'll just say that the integral of 1 over root of 4 minus x squared is equals to, actually dx is equals to the integral of 1 over root. We said that the first thing is to create a 1, so we shall factorize out to this 4. So that here we have 1 minus x squared over 4 dx. And then the other part is to say that this is equal to the integral of 1 over, all right? You see a 4 has a square root, so we shall say it has a square root of 2, so 2 under 1 minus, here we can split it. We shall say x over 2, everything squared. Then dx. Then it is at this point that you can let x over 2 be equal to sine theta. For you, the main important thing you need to note here is to note the form of the integral. That means you see 1 over, you just need to start clicking, and then you see how you're going to be doing it. So x over 2 is equals to sine theta. So if x over 2 is equals to sine theta, it means that theta is equals to sine inverse x over 2. Then when you differentiate both sides, x over 2, it will be a half dx is equals to cos theta d theta, implying that this is a half dx is equals to cos theta d theta. So that dx itself is equals to 2 cos theta d theta. Of course, multiplied, or you multiply just a 2 throughout. Then here, now it implies that the integral will be integral of 1 over 2, all right? Then square root of 1 minus x over 2 was sine theta, meaning that this one will be sine squared theta, times dx. Dx is the same as 2 cos theta d theta. 2 cos theta d theta. 2 will cancel with a 2, and you remain with the integral of 1 over the square root of 1. This is the same as cos squared theta. Cos squared theta, then times cos theta d theta. This is the same as cos theta because, and when you take the root, it becomes cos theta. So this is the same as the integral of d theta, which is the same as theta plus a constant. But theta is sine inverse x over 2, then plus a constant of integration. As simple as that. Here, just need to know that cos squared theta under root is the same as cos theta, because the square will cancel with the root. Very amazing. This is very, very, very amazing. Let's do more. Let's do more. Number 2, the integral. Find the integral of 1 over root 1 minus 3x squared. The moment you see this, just need to know the form 1 over 1 minus 3x squared. So this is still also taking the sign substitution, because we've said that this sign substitution will always be there to integrate functions of the form 1 over square root 1, rather a squared minus b squared x squared. Meaning if they are not squared, you can look at how to make them viable to this form. For example, like here, you're going to see how technical we are going to be. So in this case, allow me to say that this is the same as allow me to say that the integral of 1 over root 1 minus 3x squared is the same as the dx, of course, the same as the integral of 1 over root, right? Then I say 1 minus. Now, if I'm to bring, because there is already a 1 already, so there's no need of factorizing out. But I need to ensure that here I factorize out a square. So I have to make this one root 3. So what I say, root 3 x then squared. So that when I apply a square, it becomes 3, and this one becomes x squared. So that is the change we've made on that concept. So that I just say let what is inside the square, that is root 3x, let root 3x be equaling to sine theta. And if that is the case, it means that theta is the same as sine inverse of root 3x. And then when you differentiate either sides, you'll get root 3 dx is equals to cos theta d theta. So dx itself is the same as cos theta d theta out of root 3. Then the whole integral will become the integral of 1 over root 1 minus root 3x is sine theta, meaning it will be sine squared theta, then times d theta, which d theta is cos theta, rather which dx is cos theta d theta, all right, out of root 3. So here you can factorize out root 3. So this is 1 over root 3. Then the integral of 1 over root of cos squared theta times cos theta d theta. So really this is the same as 1 over root 3. Then integral of 1 over, this is of course cos theta. So it will cancel with that and I'll remain with just d theta. So this is 1 over root 3. When you integrate d theta, you get theta plus a constant of integration. So when you look at this, you're going to have 1 over root 3. Theta is the same as sine inverse of root 3. So we shall say sine inverse of root 3x plus a constant of integration. But to be mathematical, you can rationalize this by multiplying root 3 up and down so that your answer becomes root 3 over 3 sine inverse of root 3x and plus a constant of integration. As simple as that. Because of time, let's also do more. Let's do more. And well. Let's do more. And here we are going to have an integral from -1 up to 1 of 1 over root 3 minus 2x minus x squared dx. For this particular case, when you're having such a function, this is sign substitution, but you need to bring in the concept of completing a square down here. We complete a square and we take it in the other real form of what other functions were. So how do we do that? We shall first work on this thing, not under a root. We shall work it out without a root. And for this case, we're going to say that 3 minus 2x minus x squared is the same as, we can begin with the negative x squared minus 2x, then plus 3. Which is the same as when you factorize out a negative, it will be negative, then x squared plus 2x, then minus 3. So that I make it without without negative on this degree 2. So because if there is a negative, there is now you can complete a square with this negative. So we first bring it into the form ax squared plus bx plus c, whereby here we really don't have any negative. So that's why I factorized out a negative. So now our negative x squared plus 2x minus 3 is the same as negative. Now we are completing a square. So when you're completing a square, here we shall have x squared plus 2x. All right. I'll leave a space here. And let me say, I'll leave a space. There's something which I will put. Then I put minus 3. Okay, I'll put minus 3. Then here, what we put here, we add a half coefficient of x squared. A half coefficient of x squared. The coefficient of x is 2. So we multiply by 2, then we square. And this is 1 squared, which remains 1. So we shall say plus 1. But because we don't want to change the expression as from what we have, we shall subtract this one this side. And in that case, we have completed a square. Because now this is still x squared plus 2x minus 3, because the 1 will go with the 1. But in that perspective, we shall have it as negative. This one here is the expansion of x plus 1 squared, then this is minus 4. So which is already in the other form. But this minus, we can multiply it inside so that it becomes positive 4. So we shall have positive 4, then minus x plus 1 squared. Then now we bring it here. It implies that our integral from negative 1 to 1 of 1 over root 3 minus 2x minus x squared dx is the same as the integral from negative 1 to 1 of 1 over instead of writing this now, we're going to say root. Then instead of writing this, we shall write this result. 4 minus x plus 1, then squared dx. So it is from this perspective that we shall say this is the same as the integral from negative 1 up to 1 of 1 over, here we shall factorize out a 4 because we need a 1. So we shall say the root of 4, right, into, there is remaining 1 now, minus, for the case of this, it will be x plus 1 squared, then out of 4. So that when you multiply 4, it keeps the same, then dx. Then from here, that is when you can continue progressive as we've been seeing. So this is the same as the integral from negative 1 to 1 of 1 over, here the square root of 4 is automatically a 2 root of 1 minus, here, since a 4 is having a direct square root, and this is already squared, so I can put under them, under one root. So it is going to be x plus 1 out of 2, then squared, then dx. So that at this point I can let my x plus 1 over 2 to be equal to sine theta, implying that theta is equals to sine inverse of x plus 1 over 2. So if that is the case, then when you differentiate either sides, right, when you differentiate either sides, we are going to have, anyway, you can cross multiply here. For differentiation, you can cross multiply so that x plus 1 is equals to 2 sine theta, if this is harder for you. So you can cross multiply so that when you differentiate this side, you will get dx is equals to 2 cos theta d theta. So now you substitute everything. So it means that you will have, if I first work it out without without the limits, it will be 1 over 2, 1 minus x plus 1 over 2 squared dx. It will be the integral of 1 over 2, then root 1 minus, since this is sine theta x plus 1 over 2, then if you put squared, it will be sine squared theta. Then our d theta, rather our dx will be 2 cos theta d theta, 2 cos theta d theta. So a 2 will cancel with a 2, and this is going to become the integral of 1 over 1 minus sine squared theta is cos squared theta, under root is cos theta times cos theta d theta, which is the integral of d theta. All right, which is the integral of d theta, okay, which is the same as theta plus a constant of integration. So now, but theta is sine inverse. So that is equals to sine inverse, all right, of x plus 1 over 2, then plus a constant of integration. But the moment you bring in the limit issue, it will imply that the integral from -1 to 1 of 1 over root, it was 4 minus x plus 1 squared initially dx, is going to be equaling to sine inverse of x plus 1 over 2, then from the limits, -1 up to 1. So this is the same as when you substitute a 1 here, it's going to be sine inverse. When you substitute a 1, it's going to be sine inverse of 1 plus 1, which is 2 over 2, which is 1. So sine inverse of 1 minus sine inverse when you substitute -1. It will be -1 plus 1 over 2, which is 0. And this is sine inverse of 1, which is 90, which is pi over 2, pi being 180. So that is what we come up with. Interestingly, and very, very amazingly done. So that is how we do when it comes to sign substitution. Okay. Well, let's have some other number to do under sign substitution. Let's have some other number to do. Let's integrate cos 2x times cos x, but this one under the root, then dx. One may not clearly tell that it is sign substitution, but it will bring itself. Okay, it is going to bring itself. So for you first work on it. You know that cos 2x is the same as 1 minus 2 sine squared x from your trigonometry of double angles. So this one implies that here we shall have the integral. Instead of writing this, we're going to write 1 minus 2 sine squared x n times cos x dx. Okay, so this part only, it is taking up the sign substitution way. So anyway, let's say maybe let u be equal to sine x, so that when you differentiate either side, it will be du is equals to cos x dx. All right. So implying that where cos x dx is, we shall put du. So the whole thing is going to become the integral of the root 1 minus 2. Then instead of sine squared u, we shall write u squared. Then instead of cos x dx, we shall write du. All right. So having this in mind, we can here factorize out. We bring out the aspect of the root. So it is going to be the square root of 1 minus root 2u, then squared, then du. I did this to simply bring in the aspect of the square either side. So I had to first make, since this one cannot be made a square direct, you just have to first put it under root, so that when you square root, it goes back to 2. So now at this point still, we shall let root 2u to be according to sine theta, so that When you differentiate both sides, you'll get root 2 du is equals to cos theta d theta. So if you do this, it means that your theta here was supposed to be equal to sine inverse of root 2 u. So if root 2 u, okay, if root 2 u is sine theta, you know, sine theta from the SOHCAHTOA, sine theta is the same as opposite of hypotenuse. So I can draw my triangle here, simplify ideas. So we have sine theta is equals to root 2u over 1. It is like as if it is over 1, whereby this is opposite, this is hypotenuse. So hypotenuse is 1, and this is root 2u. By Pythagoras theorem, to get this one, you get 1 minus this squared. So you are going to get this one as the root of 1 minus 2u squared by Pythagoras theorem. So here, it means that here du from this point, our du is going to be equal to 1 over root 2 cos theta d theta. So cos theta itself, because we need to substitute for this cos theta, cos is adjacent over hypotenuse, which will be the root of 1 minus 2u squared. Hypotenuse is 1. So that is what we have. So implying that the whole integral is going to become, from here, we shall have the integral of root 1 minus 2u squared, of which this will be sine squared theta, du is 1 over root 2 cos theta d theta, 1 over root 2 cos theta d theta. So this is the same as, I can factorize out 1 over root 2. Then this is the same as cos squared theta, right? Because the root, under the root, we have 1 minus sine squared theta, which is the same as cos squared theta under root. Let me show you that step. Under root, cos squared theta under root, then times cos theta d theta. Under root, it will become cos theta times cos theta, which is cos squared theta. So it is 1 over root 2 integral of cos squared theta d theta. All right. So here we looked at how to integrate even powers. So this is the same as 1 over root 2. We bring in the aspect of even powers, of which we say that if it is an even power, we bring in the double angles. So cos 2 theta over 2. That is how we bring in the aspect of a double angle, because cos squared theta is the same as 1 plus cos theta over 2 d theta. So this is the same as, I can bring in a 2 outside, so that it becomes 1 over 2 root 2. Then the integral of 1 plus cos 2 theta, all right, then d theta, which is the same as 1 over 2 root 2. When you differentiate with respect to theta, 1 will become theta, and this one, when you integrate cos 2 theta, it will become a half sine 2 theta plus a constant of integration. But our concepts have to end in x. They are still in thetas, so we have to end in x. So this concept here is going to become 1 over 2 root 2. Okay. Theta was sine inverse of root 2u, so we can put brackets, and then we say sine inverse of root 2u plus a half. Sine 2 theta is the same as sine theta. It's the same as 2. It's the same as 2 sine theta cos theta, then plus the constant of integration. So this is the same as 1 over 2 root 2, then sine inverse of root 2u plus, of course, this will cancel with the 2, so we shall have sine theta cos theta, all right? Then, of course, plus a constant of integration. So this is the same as 1 over 2 root 2 sine inverse of root 2u, all right? Then plus sine theta itself is root 2u. Cos theta is root of 1 minus 2u squared plus a constant of integration, which is the same as 1 over 2 root 2. Then here we will say sine inverse of root 2u plus root 2u, right? This one being power half, it is going to become, of course, times 1 minus 2u squared to the power a half. Then, of course, plus the constant of integration. Now we can bring now, because u is equals to sine x, everything has to end in x. So it is 1 over 2 root 2 sine inverse of root 2 sine x plus root 2 sine x into 1 minus 2 u squared, that is sine squared x to the power a half, then plus a constant of integration. And we can stop it at that point. Very, very wonderfully made, very wonderfully integrated. Well, from there, let me integrate the last question. I'll give an assignment for all of us to do. I'll give an assignment for all of us to do. So let me do my final question that involves completing a square still. Oh, well, let me have my last example, which is also completing a square. 1 over root 5 minus 4x minus x squared dx. Well, looking at this question, by completing a square, we can realize that 5 minus 4x minus x squared is the same as negative. I can factorize out negative. Then I say x squared plus 4x minus 5. So by completing a square, this is the same as negative. I will say x squared plus 4x All right. Plus 4x. Well, so I will say here I will leave a space because I will add a half coefficient of x. All right. Okay. Then I will say minus 5. So here we shall add half coefficient of x then squared. So the half coefficient of x, right? The half coefficient of x, it is a half times the coefficient of x, which is the coefficient of x is 4. So then squared, which is 2. 2 squared, that is 4. So here we had 4. Then here you subtract a 4 in order not to change the meaning. So we shall have our factor, or we shall have the overall thing as minus, of course, this will be minus 9. So everything is going to be x plus 2, x plus 2 squared, then minus 9. So that it becomes 9 when you multiply negative. Here it will be positive 9, then minus x plus 2 squared. So it means that the integral is going to become 1 over root. Then the whole of this, now replace it with 9 minus x plus 2, everything squared dx. So it takes us to what we've been looking at, whereby here you have to first factorize out a 9 to create a 1. And this is the same as the integral of 1 over 9. But we can factorize out it, then it becomes 1 minus x plus 2 over 9. But remember, this is squared dx. So this is the same as 1 over, when you take the root of 9, you get a 3 into 1 minus, this one will become x plus 2 over 3, then everything squared. All right, but under the root. So it is from this point that you let x plus 2 over 3 to be equaling to sine theta, so that your theta becomes sine inverse of x plus 2 over 3. Then when you cross multiply here, you'll have x plus 2 is equals to 3 sine theta, and therefore dx is equals to, because this is 1, okay, so I will say dx is equals to 3 cos theta d theta. So having this, now you are going to substitute everything there. So we shall have integral of 1 over 3 root of, it will be 1 minus, the whole of this is going to become sine squared theta, because we let it to be sine theta. So if you square it, it becomes sine squared theta times dx, which dx is 3 cos theta d theta. So this one will cancel, and you have the integral of cos theta out of root of cos squared theta, then d theta. This one will reduce to d theta, because this one itself, cos squared theta under root is cos theta. When you cancel it, it becomes d theta. So this is going to become d theta, so, which is the same as theta plus a constant. But theta is sine inverse of x plus 2 over 3. So this will become sine inverse x plus 2 out of 3, then plus a constant of integration. So every viewer is going to do this exercise here. every viewer is going to do this exercise. Then we see how best we can make it. I want everyone to integrate for me 1 over the root 12 plus 4x minus x squared dx. All right. Then it can also integrate 1 over root 25 minus 9x squared. You can also find 1 over root 36 minus 4x squared dx. So in our next video, we are going to record the integrals that involve the tan substitution. Keep braced. I remain hyper. Subscribe to our channel.